So for today's lesson, we are going to be learning about types of quadrilaterals and their properties. So here are a few examples of quadrilaterals, and I'm going to be going through those in details. Now, the first thing you're going to have to remember, quadrilaterals angles add up to 360 degrees. Remember that, write it down somewhere, and it doesn't matter, right, which quadrilateral it is. Four sides add up to 360. Right, the first one we got is a square, right? If you look at it, this is what a square looks like. And the first property is all sides are equal, right? Look at all the sides, and here I've given you with the lines or the notches over here, all the same, hence they're equal. And opposite sides are parallel. So now I'm giving to you with the single arrow and double arrows. So this single arrow is parallel to the other single arrows. These double arrows are parallel to the other double arrows. So you should know that this left side is parallel to the right side, and the top side is parallel to the bottom side. And the last one for squares is the all angles are right angles, right? From the diagram you can also see that these are in a corner, right? And they are right angle, they're 90 degrees. So now just put those boxes or rectangles in the corners and you will be able to visualize that they are right angle and 90 degrees. The next one we got here is a rhombus. That's what a rhombus looks like. The first one, rhombuses are just tilted squares. So the first property is all sides are equal. And again, notice these lines, right? It's very important that you understand these lines, right? Understand them, feel them, and that means that they are the same. Now, the next one is opposite sides are parallel. Again, like a square, I'm going to show you with single arrows and double arrows. And the last one, right, because this shape is tilted, right, you cannot think that the angles will be 90 degrees, right? From by looking at it, I know that they're not going to be 90 degrees, but they have a special property. It's a special angle property. They are the angles, opposite angles will be equal. So notice the color coded angles over here. Opposite, these two red angles are equal. These two yellow angles are equal. All right, the next shape we have is a rectangle. Right, the first property is opposite sides are equal and parallel. Right, you can sort of see from just the diagram alone, right, top and bottom will be equal and parallel. Left and right will be equal and parallel. Right, notice these double lines. I've introduced the double lines now because there's two different sides. So you can see that, see, look, single arrow and single line are parallel and equal to the other ones, and then and these ones as well. So just make sure that you are familiar with these symbols, and it makes it a lot easier. That's how I remember all these properties, just by drawing out the diagram and then putting the symbols one at a time, and then that's like how I slowly recall my memory. And then the next one, all angles are right angles. Again, this shape is not tilted, so you can see that in the corner over here, right, all of these corners will be 90 degrees. And again, put these red boxes in. That's it for the rectangles. And the next shape, what do we have? Parallelograms. Parallelograms are tilted rectangles. So again, you can still recall, right? Immediately you can already start, okay, well, for rectangles the top and bottom are the same, equal and parallel, so it's going to be the same, right? Opposite sides are equal, so opposite sides, top and bottom, are equal. Left and right are equal. Opposite sides are parallel. Again, left and right are parallel. Top and bottom are parallel. Now, because this shape is tilted, the angles cannot be 90 degrees. So that, but remember the rhombus, opposite angles are equal. So again, color coded angles, right? These angles are equal. The next shape we have here is a kite. You know what a kite looks like, so this is what a kite looks like. And the first property is two pairs of adjacent sides are equal. Remember this, notice the adjacent, right? It doesn't say opposite, it says adjacent. Adjacent means next to each other, basically. So here, this top two sides are equal, the bottom two sides are equal. right? From the diagram, you can also see that. And the next one is diagonal intersect at 90 degrees. These fancy words, right? Diagonals just mean that the line go across the shape, basically. So these two lines are diagonals. Intersects means that they just cut across each other, go across each other, right? And they meet each other right in the middle over here at 90 degrees, right in the middle, 90 degrees, 90 degrees, 90 degrees, and 90 degrees. They add up to 360. And notice that this shape, the yellow thing given, is a square also. So it's all there. And the one thing that I want to add on to is that this diagonal intersect this diagonal in half. That's why I'm giving you with these lines, right? So notice that, and then make sure that you know this. And the last one we got is trapezium. So trapezium, this is what a trapezium looks like. And one pair of opposite sides is parallel. So very easy to remember. Just one pair of opposite sides. Which one do you think? Which ones or which sides do you think will be parallel? Just have a guess. Top and bottom, right? You can see from this, right? These two not going to be parallel. So top and bottom are parallel, and that's it. They are not going to be equal because clearly they're not from the diagram, you can see. Then that's it for trapezium. But the only thing that I want to add on as well is the height, right? Usually people think these sides are the height. That's how, just immediately when you look at the diagram that people go, okay, yeah, that must be. But those are just sides of the trapezium over here. So if you want to know the height, then either it is given in the question or you have to draw it from this vertex over here to the bottom side at a 90 degrees will give you the height of the trapezium. That's it for today. Thank you for listening, and excuse my cat in the background as well. Thank you very much.